couple years ago now, I reviewed this Bantam Tools desktop CNC. At the time, I paid $3,600 for it. It's now $6,500 just a couple years later. If you remember from these previous reviews, I never even tested the software or the actual cutting. I did play around with the software a little, but I never actually cut anything with this because it was just so terrible. And it was, even at the time at $3,600, it was way too expensive for what it did, and now it's $6,500 and it looks the same. I thought it was time for a follow-up. This is the Bantam Tools Explorer. This is $4,000 at the end of 2023, and it's quite a bit smaller. This says it weighs over 70 pounds. That's not true. It was 51 pounds when I weighed it. So yeah, so some of the claims I'm wanting to look at is that the spindle is 23,000 RPMs up to, it's 10,000 to 23,000. And it says 200 watts. I don't know if that's input or output. If you remember last time, this was just being controlled by a quadcopter. The spindle was just being controlled by a closed loop quadcopter thing. They'd made a claim that they were the only closed loop machine in the market space. That's not true, but whatever. Let's see, the material removal rate in 6061 is 0.1 cubic inches per minute, which is quite low. It says it has a built-in 2.5D auto cam feature in their software, which is free. So that's cool if that's the case, to have a built-in, you don't have to use F360 or whatever. So I figured, hey, let's unbox it. I did want to note that this box almost tore open on the bottom. The tape is torn almost all the way through. Basically, it almost just dropped the machine out of the bottom there. So here's the new box here. And there's some stuff in here, some really cheap wrenches. This is their spindle belt tightening thing, so that kind of leads me to believe that they haven't really changed their spindle at all. And they have a cardboard handle you would use to pick this up out of here. So sure. I'm gonna set this on the floor and we're gonna pick it up out of frame and set it on the table. Honestly, that's a neat touch. The packaging is actually quite a bit improved. Last time there was a ton of packaging. This time they've way reduced it down. So yeah, what do we got? We've got knee stop. We still have a stepper sticking out the side here. We've got a micro SD card here and USB, and then some kind of bump out here. This is for some accessory. Here's a couple more. Fan with an air filter, power switch. It's quite a bit smaller. Oh, the spindle is actually much different there. Wow, those magnets are strong. This is polycarbonate. It's 1/4 inch polycarbonate. That piece will stay there. So the hinge is actually interesting. I don't know how long it'll do that. Okay, so what do we got here? A double belt pulley system with a polycarbonate with a rubber band attaching it. This should have a better attachment. And you can see actually that they have some detents here on this folded piece that was supposed to retain this, and it either didn't work well or it vibrated. Wow, this is actually side specific. I would have maybe that to where you could put it on either way. I imagine this either rattled or it rattled off, and so they just put a rubber band around it. Yeah, that's just a folded piece of poly. We can verify that. Nope, that's not, that's glued. Why would you glue that? Okay, that's really dumb. This should be, okay, fine. I guess we're still learning, I don't know. This is a piece of CNC cut flat polycarbonate. Presumably my goal was to see if it would break, but it's just glued together, but it's certainly polycarbonate there. But God, that is really poorly designed. So we aren't gonna be using that. Oh, okay, I was gonna say, wow, that sounds horrible, but it's because the spindle is actually encapsulated in shipping foam. So that piece comes out there. So we have some more shipping rubber bands. I presume that they have instructions that tell you how to do this. They don't include the instructions, so I'm gonna just be Joe Dumb Consumer here and take those off. Okay, so the spindle is quite a bit different actually. Is that the motor though? Is this the motor? So this spindle again is rated for either 200 watts in, probably, or 200 watts out, which would be insane. But there's no way that this is still the quadcopter motor here, and there's no way it can handle that power continuously. So that would be an absolute peak number. I would imagine, I'd be surprised if this motor was rated for more than 30 or 40, maybe 50 watts. The air filter on the back was actually for the build volume here, and you can see there's actually some debris in here. So they do actually test the machine that it is working properly. pretty small build area. Let's plug it in. And we'll pop this on. Same controller. That is the exact motor controller from before. We now have a fan in there, which we didn't have before. So presumably there's a fan there. I hope the fan is blowing that way. Let's find where this magnet is so we can spoof that the cover is shut. There we go. Yeah, okay, so we are blowing air, we're sucking it through the electronics enclosure, and then we're blowing it out here onto the spindle-ish to keep the spindle, you know, that's an interesting use of just having one fan. Hey, the lights turn red when you e-stop. We'll see if that's been done safely. So, is this an M2.5? It is. Hey, we're using the metric system. There's our fan on the e-stop here. Here's this exact same motor controller that we used before, at least by appearance. So this is the brushless motor controller here. And this is actually just a reed switch. So this is not a Hall, this is a reed that's the magnet. When you put the magnet there, this reed switch flips. The magnet's not actually lined up to the reed switch properly. It's actually down by about a centimeter, but it does work, so whatever. Now this does appear to be, except for the brushless DC motor, it does appear to be entirely Bantam's design at this point. So we've just got an Atmel MCU. We've got a bunch of these, what is that? I think that's Trinamic. It's the TWC2660C. Yeah, so that's just their stepper controller. It would appear they have support at least for the two-stepper drive axis, but they're driving this in the middle. So they are gluing the holes in this to try and keep crap out, aluminum chips and whatnot. It's crazy, they have a grommet for just one, yeah, just the probe, and I can actually see through in there when I pull on that wire, which means chips will certainly get through there and then maybe get sucked up through the motor. Whatever. Okay, so Chobo Rev A, that's, I guess their internal name is Chobo. Okay, so what is the relay controlling? It's certainly controlling our brushless DC motor. It's also controlling one of the sets of wires that goes back there. So if I unplug this, it still makes sound, but I don't know what. Okay, let's plug that back in. Got another little crawl chute. This is going to the top. This just looks like an extension cord, but it actually has 4 wires in it, but this just looks like a garden extension cord. This is our 3-phase motor controller with non-heat shrunk pieces. So they put the heat shrink on here and then they forgot to shrink it. This is to keep these from shorting out. That's just a manufacturing issue, fine, whatever. No idea what that is. There's a blue thing. It has nothing in it, so that's just tucked in there. I guess maybe they have some feature. This is weird. This is a stepper. Oh, they've put some ferrites on here because the stepper was making too much noise. So there's ferrites on all of those. That's an expensive little cable. We've got a micro SD there. I've kind of pointed that out. A couple headers, debug header. That's probably the programming header. And there's a header that still has the pick and place capped on tape over it. So whatever that is, it's some kind of accessory maybe. I don't know, but they haven't even used it. Okay, so our power is coming from the other side as I had thought. And it's just on this little small bump on the bottom. It's got a little bit of shipping damage here. Yeah, so there's quite a bit of shipping damage. Hopefully the rigidity's not from the case, because your machine wouldn't be square. If you remember, this piece of foam was on the bottom. I suspect that it was kind of like that. And so there is some shipping damage here and there. Maybe they need to improve their packaging there a little. There were quite a few cables running through here, which was surprising to me. What do we have? We have a stepper. I don't know why there's, actually, I still don't understand the, 4 positives and 4 negatives there that are all the same color. So obviously they're just running probably multiple wires in parallel. I don't know why they wouldn't have just used a single larger one, but we will find out when I remove the other side. Yep, same supply there. This is LRS 35024, same as before. This is a voltage select switch there that you can switch it to 240 or the 120 on. I will note that this power supply is not legal to sell in Europe because it doesn't meet the power factor requirements. The AC does not leave this domain. Our AC domain is here to there, nothing else, nowhere else. Big old ferrite chunker here, but this is totally ridiculous that they're running 6 different leads. The amount of additional work that takes They should have just used a bigger wire, or honestly capacitors on the other side. Any one of these pairs would probably have been fine. So this is silly, but it works. I mean, if it works, I guess. We have all of these attachment points here, and then yeah, they actually have an adjuster cog here that allows them to square the machine. Now, as you adjust this out, because we're pulling this from that fixed point, it's gonna actually change the distance from these two, which can in a way help preload your bearing, but this is not well implemented. They've got an adjustment screw there, an adjustment screw there to presumably make this square. We've got all these attachment points to this piece of thin sheet metal, particularly with the shipping damage that we incurred here. This wasn't protected at all, and so when this got dropped in shipping, obviously that's what bent this foot, and it is actually quite bent. So this got the UPS treatment. UPS is my favorite of the shippers, but they're all kind of bad as far as treating your poor packaging with care. So you need to treat your product with care, because they sure are not going to. Yeah, but this power coming in, it's not only expensive and silly, it's completely unnecessary. This board has way too little capacitance on it. You could, again, with just these one set of these wires, because this thing is only pulling up to 350 watts is what it's rated for. You could certainly do that, 15 amps across this, maybe go down one size, and then you could just have one set of wires instead of 4. I was playing around with this connector here and I actually noticed there's parts on the back, so let's take that off and see what we got. One other thing I've noticed throughout this build is they just don't use washers. All right, what do we got on the back? Yeah, we actually got a lot of stuff on the back. We've got some diodes here, ferrites for power supplies, presumably. I just noticed some buttons too. I don't know why they put parts on both sides of this board. It is so empty. It's an expensive operating step. I mean, look how much room is on this board. And it's weird they didn't fill their ground in here all the way. There was some kind of keep out on the ground plane right there that made these really awkward square ground planes. Anyway, yeah, that's their circuit board. Certainly much improved over what they had before. Hopefully this relay is rated to handle DC, because if not, I mean, if you saw how much it sparked earlier, that relay is going to do that every single time you turn this on. Every time you open the case, it's going to click. I don't know why it didn't click just there. So apparently, that's fun. So we've got this switch in a state to where it's not detecting the covers open. I think that the cable is damaged here. Yeah, so actually so this actually has a short in it. It has loose wires here. So that's pretty poorly done, especially because it's a safety feature. These are really poorly manufactured cables. I'm just looking at all the loose ends on them. They're not done well. There's another cable right there. Look, here's some more unshrunk heat shrink. So yeah, there's some QC issues. I'm gonna just take this cover off. Gosh, this is heavy. That's quite the polycarbonate cover there, and certainly much better made than the one that covered that belt initially. The handles are neat. That's a neat touch. The old machine didn't have handles, and it was way too heavy to not have handles. Okay, so here's our blue tube again that didn't go anywhere. Spindle looks different. It's the same collet though, so it's not gonna have a whole lot of mass. Man, you can barely reach that with this little light that they have on here. You can barely reach the ER11 collet chuck there. But yeah, the case of this is what's giving it its rigidity. I don't like that, as I've mentioned a couple times. This is just rubber, so maybe that's just to make it look more attached. It's not protecting anything there. But yeah, there's just a piece of rubber jammed in there. They've got the same camber adjustment there that can lift and lower, but only this side of the bar. So only this one moves. So on the top here, we can adjust both of these in or out, but on the bottom, we can only adjust this one. We cannot adjust the back one. That's a bit funky, because now instead of adjusting this up, we're just adjusting it up like that. I mean, overall, I'm not very impressed. So we got limit switches back there. I believe that's the same limit switch we had before. It's just a mechanical with a bump stop on it. So not terribly accurate, but that's why you have probing. Let's pop this table off. This is a very small table, and there's that one. So here's our test piece. Yeah, so this is the test piece that they machined on here, just doing some cuts. There is certainly some chatter in this machine. You can see these cut marks on the top. and over there as well. I wonder if they're still, I think before on the old machine that they were actually squaring this top face by actually machining it. Maybe they're doing that here as well. Who knows? So typically you'd want to put a slot in one or the other of these. So you'd put a small slot this direction because otherwise the two pins aren't guaranteed to line up. They haven't done that, which is why it's so difficult to remove. Here is some T-slot nuts. This is a wide slot. They really should have used a much smaller slotting system here for a table this small. I do want to pop this off. I want to see if we still are using that circuit board solution that they were using last time. The electrical insulation layer is happening at the bolt head level here. So if you get any chips in here, that'll obviously ruin that. Of course, if you get chips around the side here, it's going to cause the same problem, but maybe you could vacuum it out. They've spaced this off so there is actually a gap between the bottom of here and the top of that. So you can certainly get debris in here, but it doesn't really matter. Yep, same as before. I mean, same concept. A rev 0.1. It's thin at least so that as it compresses, I don't know why they have a trace on one side, but okay, fine. And then yeah, they put those on here. So these are just pillow blocks floating around. That's fine, I don't have any complaints there. That one seems pretty loose though. As you adjust this, because it's not pulling it with a radius with the center point right there, it's going to make the bearings here bind because the distance between these is going to change ever so slightly, but certainly like by several thou as you go across this adjustment range. So basically this is our datum point. The collinear point through here is our datum point, and then I guess we square this to that so that these are in the same plane, and then we adjust these after the fact there. Now what does that not give us? We have no way of adjusting the bottom here, and so we actually cannot square this axis there because this is not adjustable left and right. So yeah, we could never square that axis. We do square this axis here. This is the same problem they had before on our z-axis here. There's not enough width. In fact, this is less width than they had before on their old z-axis mount here. You really need more space here, or it makes it to where this can move quite a bit. I don't know what I just bent. There's actually wires down there that you can hit. Okay, fine. That's for the light, I guess. Let's start looking at the spindle. Again, this is just an off-the-shelf brushless DC motor, just like it was before. 2 belts this time. Last time they had that really terrible belt. But this spindle appears to be the same that it was before, just mounted much more reasonably this time. My goodness, that last one was bad. So where does our spindle mounting tool go? I'm gonna pull, this is the old one, but it's the same one as before. To be honest, I'm not sure why it's included because I'm not sure where it would attach. Before it was to tighten their belt. Maybe it still is this time. Maybe this is just included by accident. Okay, so let's get these belts off. I assume, yeah, there's no way you could put 200 watts through these belts. They're way too loose. So there's one belt, 100 watts worth. And here's the other belt. We're gonna just pull that up and then off. There we go. So yeah, there's -1 chance that that would hold 200 watts. That's just our brushless DC motor there. And here's the actual spindle itself, which I'm going to now remove. We're gonna go ahead and just heat this up again because I think it's glued. My memory from last time was that this was glued on. There we go. That came loose pretty reasonably. Okay, so there are the bolts and the 3, this is so silly. So they have 3 pins here, but the 2 of the pins there, oh, they have adjustments there, but only on one side. Okay, yeah, so that does work. They mount to this pin first, and then they can, by screwing these one way or the other, they can square it one way or the other, and then they tighten down these bolts. I will note that their probe, even though it comes all the way up to here, does not actually account for the noise in the bearings on this spindle. So really they should have a wiper on the spindle that contacts there, because those wipers are much better than the bearings are. So they've gotten rid of the noise from 2 sets of bearings, but not the actual spindle set of bearings, which is moving at 23,000 RPM is their claim, which I believe the claim, because it's just a quadcopter driver. Okay, so now we need to get that off. This pin on the bottom is sticking. Okay, so I think once again these pins probably need a slot instead of 2 holes. So one of those holes should be a slot. But yeah, they definitely need, yeah, they actually have a slot there. But yeah, it was just sticking. It's Bantam. They've got the Bantam thing there. So these are just off the shelf I2C. Oh, look, there we go. So here is some mounting stuff. This is slightly different than before. So there is some difference here. Yeah, here's what I was trying to do like an hour ago, is come in here so I can access the back side of these screws, so I can take this sheave off the back. We have 3 Belleville washers here, and they are in parallel, so that's just giving us 3 times more force. And this is actually pressing from the outer bearing into the back of the metal piece there, which is an odd way to do it. I mean, I suppose the preload there is light enough that it's not going to bend that metal. But yeah, there are 3 Belleville springs, and then we've got a spacer there to keep that pulley high enough. We're definitely pushing this bearing better than we were on the last one. Yeah, that's just holding us in place there. And then this should tap out. What is this, 6,800? So this is not a angular contact bearing. Same in the last one where they didn't use an angular contact. You should really use an angular contact bearing, but whatever. This is now a sacrificial screw. Yeah, there it goes. Okay. So yeah, there's our spindle. This moved on there. Okay, yeah, no, this is right. This is shouldering on that. Sorry, it had kind of moved. They just have, this is just an off-the-shelf. You can buy this for $5-10 on wherever. And then they have a sleeve here, and this sleeve is rotating there, but it's not really adding to the inertial mass really of the spindle, because there's lithium grease on this. So if this were to snag while cutting, for example, like as your flute's going in to cut, this is going to be able to just keep rotating. So I wouldn't actually count this as any of the inertial mass. So once again, that's all the inertial mass we have. Very, very light. You can see my previous video on that. This is a better design than before. It's still not a great design, but it's better. Yeah, all right, well, there's that. Let's look at this motor next. Yeah, this is just some laser rebranded 7134 motor for a quadcopter. This is not a $4,000 machine, the hardware at least. For this price range, yeah, man, there are so many other, I mean, pretty much any other option is better. This is probably 500, maybe $550 in parts. And 550 is high, to be honest, at that number. This enclosure is probably, it's actually a little bit of a complicated enclosure, so I would think that this enclosure would actually probably cost maybe 70 or 80 bucks even in quantity, particularly if they have squareness requirements, but I doubt they do. Yeah, I have some major concerns, as I mentioned before, about keeping the squareness of this machine. The last thing I wanted to look at is I wanted to look at what we're doing now for our linear motion. And I think, again, it's just a Delrin, but it's certainly not actual ball raceway, which is interesting because in quantity, you can get those for like 20 bucks a piece. And so it's like you're talking $60 you add, and it's like the hugest upgrade you could do to this machine besides not use the external enclosure as its mechanical support. Okay, so there's our little aluminum end plate. There is our Delrin preloaded. God, that preload is so light too. So yeah, it's just plastic, just like it was before. Not great. I wasn't impressed last time. I remain unimpressed now. And again, as I mentioned already, this is way too small. You need quite a bit more length here to get the rigidity you need. So yeah, that is, I guess, how they're leveling this. You really need to use shims there. I guess they're just using these instead of shims. But that's how they're adjusting that direction, which is weird. That doesn't make sense. Maybe that's just for a rough adjust. But really, this should just be flat down. Let's see. Let's find that mating plate. Here is that mating plate, and it's flat. And then it goes down like that. And okay, so they do have adjusts here, yeah. So yeah, they are using this to adjust. Oh, yikes. And then yeah, they're pushing against that edge. That's why this was so hard to take off, because it's also having to bend this pin as you do that. So yeah, okay, yeah, that's not great. I am very happy to see that they've moved to just a standard clamping M4 bolt here, so that you can actually remove these shafts. It was completely asinine that the old version didn't do that. It had crushed pins so that you basically could not remove these, which made it irreparable. Couple notes while I'm putting this back together. I'm at a point where I need to square this, and I noticed that they didn't actually include a collet nut. This is my own collet nut. It's an ER11, so it'll work, but it's gotta just be an omission. They just forgot to include it with my kit. I did have one comment on this Bantam light bar. Where it goes in here, they've added some glue here. I'm not sure why, just to probably keep the lens in place. I think this is supposed to cool to the aluminum, but there's actually nothing, there's actually a gap there, so they should probably put some kind of thermal gap pad there, or put a spring on this side so that it pushes back into it, still with some thermal paste here. That would cool it better if that's an issue. But I think the bigger thing is that there's no conformal coating on this, and the 3 ground VCC and transmit are actually exposed here, and this is right by the spindle, so Chip is almost certainly getting it in there. They really need to glue that, at least so that Chip isn't getting stuck there. There's plenty of other places that Chip could get in there, but I just thought that was a bit odd. What else? I had a couple of other notes. One, there's no way to pre-tension this belt, which means I think that this was included in error. Reassembling the spindle was fairly painless. I did have to take it back apart a few times just because of the order of operations is important, but that is reassembled. Now I do have this just loose on here right now because the way that this works, which again I've already commented, it's a really neat concept, but unfortunately the implementation doesn't work. So basically what they're doing, we'll go ahead, oh, one last thing. They do include a 2-inch straight 1/4-inch shaft. I'm not going to use that for squaring. I'm going to use a 3-inch shaft that I have, just because it's a little bit longer. They do include this ER 1/4-inch. It's an ER11 1/4-inch collet, so we will use that with our collet nut here. And what we are going to do, once I get this to thread, I can't make any comments about how difficult that is to thread or not, again, because they didn't include the collet nut, so it's possible that my collet nut, which works just fine on my machines, I don't know, I will withhold any judgment there. So I'm not sure if this shaft isn't straight. I'm sure it is. This is my own shaft, but there might be a ton of run out on this spindle. So let's see. Yeah, we definitely have some visible run out, and it's probably more than 2 or 3 thou, maybe even 4 thou. Let's measure this run out. Man, there is just not a lot of room in here. Let's do that. We'll go 1 inch down because it looks like this is for a 2-inch tool. Okay, now, gosh, very little room in here. Let's rotate this. Now, of course, that's not run out here. I mean, so this is the actual rotational run out. This is just the slop in the machine. Oh my goodness. That is not great. We ran into this problem last time too, where our poor little Starrett gauge here, which is measuring in 10,000ths. And so last time we had to use a much more, this is measuring in thou, so this has 10 times less, but we have quite a bit more travel, and it would appear we're gonna have to do the same thing there because this thing is just beyond awful. But you can see again that there is a lot of flex on this machine. Before we go into the actual Bantam software, I just wanted to play around with this on the serial monitor. First thing I tried to do is just kind of get some info, and the first command I typed worked because this is just using an open source TinyG or whatever. One thing I did notice, so you know, these are just all the parameters or whatever. If you type this in twice, man, it goes crazy. I think there's some kind of interrupt issue there because it basically prints that out too many times. It's the same thing every time. But if we just do it one time, you know, I kind of wonder if we do it 3 times, if it's going to be even worse. So it actually, yeah, so it actually ignores that. So there's basically a command for 1, there's a command for 2. I wonder if this is dribble like, yeah, so Synthetos. Yeah, so that, you know, you see we're using a lot of open source stuff. Yeah, so something about the show all settings is really messed up there. It's just not implemented well. G0, X minus 1. This should probably tell me I need a home, but it didn't. So it didn't even ask me, and now it's just spitting a bunch of stuff out. So let's do a G91Z plus 30. So we are defaulting to millimeters. Yeah, there's just a lot of data being sent. Not sure why. Yeah, it's just some kind of machine state status, and then all of these. This is a lot of data to go across there. It's amazing to me I didn't have to home. Let's just kind of crash it. Let's do a G91Z plus 50. Yeah, so it's just not even looking at the limit switches. Wonder if that is, so that's crashed pretty hard. Let's do Z minus 1. Okay. Let's see if we can spin that spindle. We're gonna do M3S 10,000. Nope. M5? M3. There it goes. Ooh, that sounds horrible. I kind of want to test something out here, because if you remember last time, we weren't able to crush a can. So G91, G0, X plus 10. There we go. Let's see. That looks good. Just put that right off third. See what happens. So we're gonna do, we'll hold that again once we start. We're gonna do G1 F100 X minus 200. Yeah, let's see what happens. Yeah, well, we haven't fixed that. So we still don't really have any power, and we didn't before either. Kind of embarrassing, to be honest, but okay, what else can we try to do? You know, before I put a dimple in this can, and I'm gonna do that again, but gosh, I'm gonna put a lot of dimples in this can because I know based on my experience 2 years ago that there wasn't a chance that this was gonna happen. So let's put that right there. We'll do a G1. First of all, we're gonna, what is this? G1 X minus 200 F 100. That's pretty slow. Went the wrong way. Yeah, interesting. G91, G0 X minus 20. Okay, I don't know why it keeps crashing that way, but check this out. I'll put that in the middle. G91, relative motion, G0, X minus 10. That should move that way, and it doesn't. So now we're going to do the same command, but we're going to say X plus 10. Doesn't make any sense to me. There, now it works. X minus 10 is what we wanted, but it's not initially. Okay, so let's reset this again. So we are going to do G91, G0, X minus 10. It should go that way. It doesn't, right? Kind of weird. If we repeat the command, it still doesn't. But now if we go positive, it still goes that way. And then if we go negative, now it goes negative. So that's pretty messed up. That's very repeatable too. So here, I'll reset it. I'll show you the exact same behavior again. We're in an initial condition here where this does not behave correctly. And we're going to issue the command to move left here. It should move left, and it moves right. And it will keep doing that until I do a right command, which does move the right way. And then when I go left, Now it goes left again. So our motion is messed up, but I've never seen this before. Pretty wild. Let's see if we get the same thing on a Z. So we're, while we're here in this presumably known good state, we're gonna move, so Z is also doing the same thing. So I did Z minus 10, we're in G91, we should go down and we don't. So if I do Z plus 10, we still go up, and now if I do Z minus 10, now it works properly. So very repeatable behavior, very silly. What an easy bug to find. I don't know, any test you did should catch that you're going the wrong way. So I opened up Bantam and downloaded the latest version. Now the first thing it's telling me is that it wants to update the firmware. And it's possible that doing this is going to fix that negative issue. So let's see if this works. So full chip erase failed. And so, okay, let's try again. I'm sure that machine is just totally bricked at this point now. So restart to change machine type. Okay, so the Bantam milling machine used is a different model than the one currently being displayed. So to load, click OK to quit and then restart. So we're gonna restart Bantam. Yeah, so they don't have a developer certificate still. They didn't 2 years ago either, but they certainly don't now. Yeah, so current firmware unknown, we're going to do 10114, so I think that's a different number than we had before. Yeah, so we've bricked the machine at this point, so I guess that ends the firmware update process. They had a method to where you could manually load firmware. Yeah, well, we bricked the machine, so that is less than ideal. Hasn't been a great first attempt here. Let's try, well, I mean, this will open the window I want. Let's try that. Nope. Okay, bricked. Well, that concludes our software review of the Bantam desktop machine for now. We can play around. They say on their website it doesn't actually require the machine and it's free, so you might as well play around. I want to see their new 2D stuff. New cam, there we go, that's what I want. Okay, conversational cam. We're gonna do nothing because that costs $30 a month, so $1 a day. I thought I had 2.5 dimensional cam. That seemed like... What features come with free version? Built-in 2.5 dimensional auto cam. How do I use that? I was kind of expecting this to work, but it doesn't. I mean, honestly, it doesn't look like a whole lot has changed here in the last few years. I'm sure that some things have. It would be nice to use the machine. It'd be nice to do some of these jogging stuff. Set to Explorer. Hey, that's what I want. Your default has been changed to Explorer. Let's see if that'll let us. All right. Could not connect to the machine. Well, guess we'll be contacting support at bantamtools.com. Well, thanks for watching.